Well, hopefully we're all much more familiar with our nav tools. This week we are going to talk about compass error. That's always a big one. And then next week we're going to dive into our distance, speed, and time calculations. So if we're good to go, let's dive into the PowerPoint. I don't really have any other announcements. You know, I post the recordings on, why can't I share? Oh, I post the recordings on the Google Classroom. Everything should be up to date on there. Okay. Make sure I can see it.
Hey, Bree, this is Carol Suzuki. I had a quick question on the homework.
Yeah, go ahead.
So in assignment 4, it had question 4, what is the course direction from Gayhead Light to Brenton? Wait, was that the one? Brenton Reef Light. And I think I was having trouble identifying Brenton Reef Light, if I'm recalling correctly. I had noted this to ask you about it.
Okay.
Is that I was assuming actually that was like a lighthouse, but maybe it's not a lighthouse. Maybe that was my confusion.
Correct. It is both Brenton Reef Light and what's the other one we use? It's on the chart. The Buzzards Bay, Buzzards Light and Brenton Reef Light are in the middle of the water.
Okay.
So they're surrounded by water, but they're fixed to the sea floor.
Okay. So
it's on some sort of structure.
Got it.
And that is why it's a fixed light. So you're going to see it surrounded by water. Okay. But to correctly identify it, use the symbol. So use that dot with the teardrop shape versus the buoy with the diamond shape.
Got it.
And then the light characteristics.
Okay, great. Thank you.
What the heck? Hold on a second. I've now split my screen. I'm trying to, hold on, bear with me for a second here. I had a bunch of technical difficulties last time, but I figured that all out. And now, display. Okay. Okay. Okay, is everyone looking at the chart on PowerPoint? Is that what you see? Okay, cool. Okay, yeah. So I did get a couple questions of using that training chart versus what the actual chart is. So I just wanted to show you a picture of the latest chart for that Martha Sound Buzzards Bay area. There's a lot more and a lot different things than like what we use on our training chart. So don't use that training chart for navigation. It's just for the Coast Guard still uses the same old training charts that they use forever. I don't really know why we are using the training chart in this class, but that's how the class was designed and I just kind of went with it. I guess that's a great answer, but anyways. here's that Brenton Reef light, Carol. I didn't even know I'd have it on the slide. Now it does not exist, but it existed back in, I don't know, the 80s or the 70s when that chart came out. But now they don't even have it. So they have a buoy, a safe watermark instead. So anyways, we are going to talk about compass error and compass correction. Let's see. Okay. So we're going to kind of start with the basics of a compass. So a compass is what we're talking about when we talk about compass is direction. So we have north, east, south, and west with our, I'm trying to get my globe, hold on. Whoop. Right, north is going to be pointing to that geographic true north spot on the top of the earth. So that is our kind of our reference point for a lot of what we're doing. So it is 0. If we give a value to it, it's going to be 0. And then moving clockwise, going around to the South Pole would be 180. So that's 180 degrees from the North Pole. That's a reciprocal, if you will. So these are just kind of units of degrees, or these are units of degrees, but sometimes it's easier for you to communicate with people on board to say, oh, it's to the west or to the northeast, or just to say it's at 045. So it's kind of depending on your crowd, how familiar are you on the number values versus those word values. That northeast is the same as 045, or west is the same as 270. And the reason I say 045 or 090 is because there are 3 digits. You can go from 0 to 360, and 0 are the same. So you can go from 0 to 359. And so you always want to have that placeholder, that 045. And technically you're supposed to say 270 instead of 270, or 351 instead of 315. But anyways, that's okay. So a compass, whether on a compass rose on the chart, is going to have all the numbers, all the values in numbers. It doesn't have any N or E, S, W, or any of those. Your compass card on board your vessel will have the numbers as well, most likely, as well as some of the lettered values that go along with it. And they're pretty much, I'm going to say they're pretty much the same, but I know we're going to get into pictures of other compasses on recreational boats. They look a little bit different. Here we go. So it doesn't quite look like this picture on the left-hand side on a recreational boat. Some recreational boats do, but some do not. You might have more of this dome-like one. And when we're looking at a compass, the compass is always pointing, that compass card, so that actual disc, this little disc, is always pointing to north. And what moves, the lubber line, is the thing that indicates where you are pointing. And that lubber line is stationary with your vessel. And our vessel is moving around the compass. So it's not the compass that is turning, it's the vessel that's moving around the compass. That compass is always going to be, if it's a magnetic compass, it's always going to be pointing to magnetic north. And then the vessel is what's moving around it. So it's hard to conceptualize because we're standing on board and we see the compass turning. We think, oh, the compass is turning, but it's us that is turning around the compass. So we got to kind of think about that in a different way, if you will. Okay, so yes, that compass card is what's floating in that liquid. And then the lubber line is what's on kind of the outside, and that's in line with the center line of the vessel. So that lubber line is going to be, if you were to draw a line through, you know, bow to stern through the center line of the vessel, it's going, even if it's not on the center line, it's going to be offset and parallel to that. So it's kind of pointing ahead. Here's another picture of the lubber line with the floating card. They can look different on each vessel. Different types of compasses. So we have a magnetic compass. That's typically what you're going to see on board. You also might see a satellite compass. They'd have to have a satellite and then a repeater or reader, so you could see what the satellite compass is pointing to. And then you might see, probably not, gyro compasses. That is what larger vessels use. And the gyro compass is kind of in a closet hidden away, and it looks like that. And then you have the gyros compass repeaters throughout the vessel that you use. So again, this image kind of on the bottom right looks more like that compass card or like that compass rose that we're looking at. And that's what we use on larger vessels. This middle picture here is a picture of a magnetic compass on board. It's called a binnacle. They still have them on board, every single commercial vessel, but I see them a lot in you know, like nautical antique stores and stuff. They make them pretty cool. But you can move these black balls, and then there's discs throughout this tower thing to kind of adjust that magnetic compass. And we're going to get into that a little bit later. In order to read that magnetic compass, commercial vessels use this kind of like a periscope and mirror to read what it is saying. So you get an actual readout of what that magnetic compass is in the wheelhouse. You don't have to see wherever it is, because you want it to be kind of as far away from electronics and other things as possible, which we're going to get into. But anyways, so those are our types of compasses. Again, you guys are most likely going to be using magnetic compass, satellite compass, or a handheld type of tool. Handheld compass. Back to labeling. They're back before, back, I don't know, in Viking days, early on in sailing, they would use they didn't divide up our circle by 360 degrees. They divided it up by cardinal points. And there was 32 cardinal points. So right now we have 360 divisions. But before that, we had 32 divisions. And those are called cardinal points. So those are your north, northeast, or south by west. You're basically dividing up the compass in 32 points and giving it a degree with the letters, with the south by east or southeast by west or whatever it is. So a point is worth, or is basically 11.25. So this one comes up a lot because sometimes if you're looking at your compass, or not your compass, a triangle or another nav tool, I'm going to show you on here real quick. So on my triangle, I have 360 little spaces on the outside, and then I have these marks on the inside of my triangle, and those go with the letters. You can see the letters northeast, southeast, etc. Those are not going to line up exactly with these because these are in reference to the cardinal points, which are 11.25 degrees. So you don't want to line up your lines with these. We are in the 360 degree, more accurate era of navigating. So we're going to use all the ones with more little lines, if that makes sense. I feel like I'm describing it a little strangely, but okay. So does anybody have questions on cardinal points or direction of northeast, southwest? You guys are okay? Okay. This is just another picture of the compass with the cardinal points instead of 360 degrees. Okay, then we have another point system, which I'm just kind of throwing at you here, which is that lookout points. And these are relative. So we're going to talk about our compass is, our reference point for our compass is due north, or magnetic north, or compass north, but it's always north, and that's our 0. And then we add going clockwise. When we talk about relative bearings, or basically relative bearings, we're going to talk about relative from the bow of the vessel. So instead of looking kind of globally at there's north, and then we're going to look around our vessel, we kind of go to our ship, our vessel itself, and go relative to my lookout points from my bow going clockwise, so that my bow is that reference point. Excuse me, is that reference point. So you have, again, 32 points, 11.25, but relative from the bow. And this is where you get the fancy terms of, you know, abaft the starboard beam or broad on the port quarter. Again, in the commercial world, people use these, but I would say most likely in the recreational world, they're going to go with the clock system. That, oh, we have a vessel coming at, you know, 5 o'clock or 4 o'clock, and kind of have that clock system as 12 as kind of dead ahead. And then, because everyone kind of knows the clock, but anyways, okay. So that was kind of our compass basics. Does anybody have any questions on the compass basics? On our 360 degrees?
Bree, could you give an example of like one of those lookout point systems and the relative bearing? Like, for example, the point system of 2 forward of starboard beam, like how would you say that?
So if you saw, you would say, there's a sailboat 2 points forward of the starboard beam, or there's tanker broad on the quarter. We have a buoy 2 points off the bow.
Okay.
So that's
Got
kind
it.
of a lookout. This is how the lookouts communicate to the navigators. And really, it's, you know, when I was at the academy, they teach us little tricks of how to like calculate these points. But in reality, it's very difficult to calculate these points. So you just kind of say like, oh, we have something about broad on the bow. And then as a navigator, I would look somewhere off the bow and see and be able to see where it is. And then I could see where it is on the radar or electronic plotter or something like that. Or it's basically, where should I be looking out the window, right? Instead of like, there's a boat out there. I have no idea where it is. Oh, look, you know, broad on the port quarter or something. Okay. Okay. So now we're going to talk about compass error. And this is where the math comes in for us. Compass error is going to be the difference between whatever compass you are using on board and true. So true is kind of that base point. Again, everything we put on the chart and everything we take off the chart is going to be in true. So if we're using a gyro compass, we're going to get gyro compass error. If we're using a satellite compass, we're going to use satellite compass error. If we're using magnetic compass, we're using magnetic compass error. So whatever it is that you're using on board is going to be most likely some sort of different than what actual true north is. So we want to calculate that compass error. And for this class, we're going to be talking about magnetic. And your magnetic compass, basically either your magnetic compass or you're in true. For those taking Coast Guard exams, you might get into gyro error as well, but probably not. So we're going to talk about, magnetic compasses versus true. Those are going to be different values, and we want to know what the difference is. So on our magnetic compass, there are two types of error that can be introduced into this. There is variation and deviation. Variation is the error is created by the Earth's magnetism. Deviation is the error is introduced by the boat's magnetism. So we have this magnetic field surrounding us on the Earth, and then we have this magnetic field that's specific to our boat or our vessel. So we have variation and deviation. We're going to look into variation right now. Excuse me. Okay, so variation is the difference between where the magnetic North Pole is pointing and true North Pole is. So there's the magnetic fields around the Earth. I'm not a geologist, but there are magnetic fields around the Earth, and there's a magnetic North Pole. So the difference between that magnetic North Pole and true, that geographic North Pole, is going to be what we call variation. So, fun facts, the Earth has magnetic fields. The same polarity repels each other, opposite polarity attracts. Over 9 million years, there's been 12 reversals of Earth's polarity. Another fun fact. Our magnetic meridians are going to be those lines of kind of equal magnetism or lines of force between those magnetic poles. And I'm going to show you a picture here. So this, before I get into this, our magnetic North Pole is not our geographic North Pole. So this is a map over the years of how our magnetic North Pole has moved around. So it was kind of moving around slowly, and in the last 50 years, it's kind of taken off. So right here is our geographic North Pole, where all of our longitude lines meet, and our magnetic North Pole has been on the move. It is a moving target. Obviously not like super, super fast, but it's getting faster if you look at it. So again, our magnetic North Pole is not the same as our geographic North Pole. These are lines of magnetism. So these are going to be those lines of, here, I'll go to this one first, of magnetism and variation around the Earth. So this is a pre-calculated number. For each chart that you are working on, you're going to read what the magnetism is in this area. So in Long Beach, our magnetism, our variation is going to be 12 east. When we are looking at our training chart, I think it's 15 west on our training chart, and it's 12 east on our Long Beach chart. So whatever chart you're on, that is where you're going to find this. So it's a predetermined thing. And when they come out with, you know, a new addition to your chart, the variation may or may not change. Let's look. I think I have this on the next slide. Yes. So our variation, it's found on the compass rose. So each compass rose has variation in the middle. It's VAR, and then it gives you a degrees, and it tells you when that was calculated or when that number was acquired. And then it gives you this annual increase or decrease of a certain number. So we are in 2021 now. So we have an annual decrease of 5 minutes. So that little unit there is minutes. And this is 12 degrees, 0 minutes east. For our purposes, we are going to use a variation of a whole degree. So we are going to round to the nearest degree. So in this case, we'd have 12 degrees, 0 east, but I have a decrease of 5 minutes per year. So over the last 4 years, I would have decreased 20 minutes, right? So 20 minutes minus the 12 degrees, 0 minus 20 minutes, I'm still going to have 12 degrees. So we're still using 12 degrees east.
What does the decrease versus increase? Does that mean it's moving back west?
Correct.
Okay. And if it was increasing, it would go more east.
Yes.
Got it.
This value is 4 degrees, 15 minutes west. So we have an annual decrease of 8. That was in 1985. I'm not going to do the math on that, but you can basically see how you're going to calculate your variation. So I'm going to say that this one is from a training chart or something. Most of your modern charts that you're going to be using, your variation is pretty recent. And that decrease is, every decrease that I've seen, that change is very small. So you typically just use that number. For those of you taking Coast Guard exams, the variation will be given to you in the question. Don't read it on the chart. It's going to be given to you in a question. Okay, but also I wanted to show you on here, one of you guys was just talking about it. I didn't see who was talking. so here's the big star in the outer circle is our true north. And our variation is this 12 degrees is saying that our variation or a magnetic North Pole is 12 degrees to the east. So over here is where our magnetic North Pole is. It's 12 degrees to the east. That's what that value is saying. Where this one over here is saying that we are 4 degrees to the west. So here's our true north, our magnetic North Pole from where we are in the world right here. Our magnetic North Pole is 4 degrees to the west. So we're going to have this value, this east or west value of which way we're going on the compass rose, to the east or to the west. Okay. Okay, there's a variation. Okay, now we're going to talk about deviation. So again, deviation is based on your vessel. So on your vessel's magnetism, or the error is introduced because of the magnetism on board your vessel versus the Earth, and that's variation. So deviation is going to be the difference between that magnetic North Pole and what your compass card is reading as north. So your compass on board, even though it's a magnetic compass, its north is going to be a little bit different than the magnetic North Pole. And that is because of the magnetism on board your vessel. So I'm going to go back for a second. Again, we have the true North Pole, and then our magnetic North Pole, and then we're going to add in deviation because our boat might be affected being pulled, the compass card itself being pulled to the right or the left, and that's what's deviation. So what can cause deviation? Throw some things out there.
Large mechanical, like motors and things.
Yes.
Radios.
Radios,
Your
yes.
cell phone.
Cell phone.
Cell phone.
Well, the battery, I think,
The battery, yes.
right?
Yes. These are all, and I'm going to say for recreational boaters, it's very easy to put a pocket knife right next to the magnetic compass, or put something metal. That's going to create a magnetic pull on your magnetic compass, one way or the other.
Handheld.
So it's just something you want to think about, right? That there's the magnetic North Pole where the compass should be pointing, but your vessel has deviation on it, which is that that error caused by what's on board. Okay, so how do we calculate this deviation? We find our deviation using deviation tables. So I'll explain my pictures here. The one on the left here is the standard deviation table from the US Coast Guard for anybody to fill out on their own. Their example is this one. And then I took a picture of the deviation table on board my husband's vessel. So that's more of a commercial style deviation table, but they're all pretty much the same. It's going to say what your ship's heading is, and then what deviation is for that ship's heading. In this class, we are going to use, hopefully you guys have got this printed out or it was mailed to you in the packet, but it is going to be our CoNav1 deviation table. We are going to use this for CoNav1, CoNav2, Celestial, any of the classes that I'm teaching. Pretty much any class at OCC, except for US Coast Guard classes. The US Coast Guard has their own deviation tables that they use for each problem. So keep that in mind. Your deviation table is going to be different on board your vessel. Your deviation table is going to be different for your Coast Guard classes. But for OCC, this is our deviation table that we use. I was hoping Ted might be here and he could help me answer this. Has anybody had experience with the deviation table on board the vessels that they sail on? Has anybody seen a deviation table?
We have one on our boat that they did when 1985 when the boat came out of the yard. So we'll probably have to redo it.
Yeah. I want to say that's pretty typical. You'd get a deviation table when it comes out of shipyard, whether it's for a large repair, any sort of repair that you're getting in the shipyard. If it's significant enough, they might swing your ship for you or swing your vessel. But I want to say, I know you can hire somebody because I've hired people to come on board and swing the vessel for us in the commercial world. I'm just wondering, I haven't experienced that in the recreational world of how common it is. And the feeling I get is that it's not very common at all. And the feeling I get is using a deviation table isn't very common. But in my opinion, there definitely is magnetism on board your vessel affecting your compass that needs to be accounted for. A lot of people just say, oh, who cares about deviation? It's going to be small anyways. But it is there. And the longer you go on a certain course, the more error you're going to get from it. So if you wanted to create one of these deviation tables, the term for that is called swinging the ship, to develop your own deviation table. You can do this at any time. Well, I guess you can't do it at any time. You want to do it in a coastal area where you have many landmarks or things around you to take bearings from. And we're going to get into that a little bit later, how to take bearings. But essentially, you want to be in a known position so that you can see on the chart, I'm in a known position. If I'm pointing my boat due east, and I know that's due east because I know where I am, and I can see on the chart that this whatever is exactly due east, I can read what my compass is saying and then calculate the error. So it's kind of this reverse way of doing it. So you can do it really anytime you want, but like I said, hearing feedback from you guys, it's pretty uncommon to do.
Hey Bree, do the black balls on that previous compass, do they eliminate the deviation if they're adjusted properly?
I wouldn't say eliminate it, but makes it very, very minimal. Yes. Okay. Because you're on a steel vessel moving containers, maybe full of steel things, possibly. So adjusting the compass with binnacle helps that. Makes it so you don't have a deviation of like 20 degrees. If somehow you calculate your deviation to over 10 degrees, maybe over 5 degrees, then you need to readjust your compass. That's a pretty large error for deviation. Okay. So any big questions on deviation or variation?
Bree, can I ask a question about variation and the annual decrease or increase?
Yeah.
I guess I didn't get how that affects the variation degree in that formula. So I understand the variation degree, but then the annual decrease or increase. Could you kind of go over that one more time?
Yes. So I'm gonna go to my whiteboard. So if we had a variation of 5 degrees west with an annual increase of 2 minutes, your annual decrease or increase is going to typically be in minutes, a very small amount, right? There's 60 minutes in a degree. So if this was taken 10 years ago, so I can say, okay, 10 years, then that means I would be increasing by 20 minutes. So if I change this, my variation was 5 degrees west 10 years ago. So I will add my 20 minutes and I get a variation, I get a variation of 5 degrees, 20 minutes west. But we are going to use variation as a degree. So I'm going to round that to 5 degrees. 5 degrees west. Now, let's say this was done 20 years ago.
Yeah, like that one that was in, what was it, 1985 with
There
the
you go,
8th
yeah.
degree. So what is that?
30 years ago?
35, 280 minutes?
Okay, let's go with that number. 280 minutes. We're going to convert that to degrees in minutes so we can add it. So let me get that real quick. So 280. Is that 4 degrees, 40 minutes?
Mm-hmm.
Yeah, 4 degrees, 40 minutes. So if I'm adding this, I'd add 4 degrees, 40 minutes. I'm left with 40 minutes, 9 degrees. I'm going to round to the nearest degree. So I'm going to say my variation is 10 degrees west because 9 degrees, 40 minutes is closest to 10 degrees. Kind of quick math there for you. But did that answer that question, all right?
Awesome. Thank you, Brie. I appreciate it. Because like at first I was like, wait, minutes, how is that affecting the variation? But then with a longer or older map or older reference to a compass rose, it makes sense now.
But the variations that you're going to see on any chart that you're actually navigating on is going to be within 5 years. That you're not going to have this 40-year annual increase that you have to calculate. Okay, let's go back to this. Okay, so we have our compass error, variation and deviation. Deviation is from the boat, variation is from the world. Now, how do we apply these? How do we calculate it? And why do we need to know them? So I was kind of saying earlier, I think it's easy to just, I don't know, neglect or just dismiss deviation because it's harder to it's harder to calculate using a table versus just seeing what the variation is on the chart. But here's my little example. If we are cruising along and we've set our boat to autopilot, cruising down the coast, if I am 1 degree off, which isn't very much, right? 1 degree. My little thing is errand. So if I'm navigating 1 degree off for the first hour, let's say this is 1 hour, the longer I navigate on this erred course, the more keep saying error, the more error I'm going to get, the more off course I'm going to be. So you do want to calculate, especially if you're going longer distances, like crossing, you know, from Newport to Hawaii. If you have a 1 degree variation or 1 degree deviation that you're not accounting for, however far away Hawaii is, that's going to be a very big difference once you get there. Now, the prudent mariner would reevaluate, because it's not just compass error that can put you off. You know, there's wind and current and swells and weather and all these other things that can put you off as well. So if you are navigating along, reevaluate, see where you are, adjust your compass, your heading accordingly, continue along, reevaluate. It's this continuation of reassessing where you are and adjusting for it and continuing to do that. So if you set your autopilot and then go down below for a nap or a drink or dinner or something, that's not very prudent to go to in the first place, but it happens because
doesn't the autopilot work on your GPS location? So it takes into account, it uses true north and also changes speed course based on current, wind, whatever.
That all depends on the type of autopilot that you have. Some autopilots literally just go by what your compass is saying. And I would call it auto track for the types of computer systems that keep you on the track line of that geographic spot of where you want to be. In my experience, we used auto track very rarely because the computer would essentially be overcorrecting for itself, and our engines and our fuel efficiency went way down versus just trying to keep a heading and then having the navigator adjust the heading as needed. That we just maintain a certain RPM and continue on. It's much more fuel efficient, but I know fuel efficiency is not your main priority, or time ETAs is not your main priority. So it all depends on what vessel you're on, what your priorities are, and what type of instruments you have. If even you have the capability of doing an auto track type of autopilot versus just an autopilot that keeps a course. Okay, hopefully that answered your question. Okay, so how do we apply these numbers? This is going to be one of our first formulas. So our compass correction formula, our basic formula here, is going to be TVMDC. That is true. That's your true course or bearing. Apply your variation. And then you get what the magnetic heading or bearing is. And then you're going to apply deviation to see what your compass is reading on board. So that true is, true, that geographic true north. The magnetic is where that magnetic North Pole is. And the compass is the compass on your boat. And then how we move through this is by adding, if we're going down, which I will explain a little bit more in a second, we're going to be adding west. So our variation and our deviation have those values, that east or west. Am I east or west of the thing before it? Am I to the right or left? And so that's going to kind of be like our positive, negative number. So these are the basic formula, if you will. And we're going to do an example, and this will make more sense with the example. But you can also work this the other way. If we had compass, if we had a compass value, then we apply our deviation, get our magnetic, apply our variation, get our true. And if we are working it backwards, kind of from C to T, we are going to be adding east. So if you've already, let me know if you guys have heard of this before. Most people have maybe heard of this before. If you have heard of it before and use the T to C, continue doing that. If you've heard of it before and use the C to T, continue doing that way. They are the same ways. Just people have learned in different. I would say the most common is the T to C. So some people say going down, you add west. I actually learned it starting at C and going to T. So I kind of always go back to that. But again, it's the same thing. You can work it forwards and backwards. So these TVMDC or CDMVT are in relation, what those letters mean is our compass, as in what the compass is on board. Our deviation, our magnetic, is in relation to the magnetic North Pole. Our variation, and then our true. One thing that we're going to see when we look at our is our units on these. So if I'm talking about true, I'm going to have degrees true. If I'm talking about variation, it's going to be whatever degrees east or west. Magnetic is going to be degrees M. Deviation is going to be whatever it is with an east or west value on it. And then our compass, some people go with compass, but you're going to see it a lot as PSC. That stands, in my opinion, that stands for per standard compass. And technically, per standard compass means, let me get a little picture of a ship here. Here's your ship. Here's that that center line, if you will, that's going down. So your compass, so the standard compass is going to be center line. But most of the time, we're going to have repeater compasses, where we have a compass that's, maybe at the steering station, or we have one on the stern. Maybe it is on the center line on the stern, or we have one on each little bridge wing, or wherever we have them off center. if you will. Some people say this is per ship's compass. That might be easier. But in any regard, just remember that the C or PSC is going to have that C, and our M is going to go with our magnetic. Any questions on that? Okay. Let's go back to PowerPoint. Okay, so how do we remember what this formula is, what all I'm blabbing on about? We have poems. We try to make things simple for our sailors, right? So very common poem here is going to be, to remember, we have TV makes dumb children. All of these poems are not politically correct, and please forgive me. I did not make them up. If anybody knows of a good one, please share it with the class. Different things spark different memory aids for different people. I'm going to show you next, probably the most common one I've heard. It is absolutely not politically correct. I did not like it. It is not my favorite, but I do like it because it has kind of the bottom part to it. So it's true virgins make dull company, add whiskey, subtract ethics. So that's you're adding west, subtracting east. Most people remember that one because it makes people laugh. If you're going the other way, from C to T, I learned it as can dead men vote twice at elections? So it has that adding east component to it. Also, cow dairy milk is very tasty. That's a strange one, but I've heard that one before. Does anybody have any other memory aids they'd like to share? Okay. Some people do.
I just have a question. We're going to do an example of the adding west and subtracting east. That I don't understand that.
Yes.
Okay, good.
Yes, we are. Okay. So with compass error, okay, so these are our kind of formulas, and I'm going to talk about compass error, and then I'm going to do some of those, some actual examples. So we will get to that, I promise. So compass error, combination of variation and deviation. It's basically, compass error is what it says. It's the difference between true north and whatever your compass says. So essentially, it's that combination of variation and deviation. And compass error, variation, and deviation are all labeled. They are labeled with an east or a west, to the right or to the left. Another way to remember this, we're going with our memory aids here. Compass best, error west. Compass least, error east. So is my value better than true or less than true? Best, less, least. So if our compass value is more than true, our error is west. If it's less than true, our error is east. But here's some more visuals to kind of explain this. So on this picture here, the outer ring is true north. So we have true north, And then that middle ring here is magnetic. So the difference between true and magnetic is variation. So we have a variation going to the west. I think that might be 11 or 12 degrees. I can't really tell. 12 degrees variation to the west. And then our compass card, when we're looking at our compass on board the vessel, my due north is pointing further to the west, or further to the left there by, I don't know, another 10 degrees or so. So I'm going to have another 10 degrees of deviation. So my compass error, my total error between what my compass is reading and what true is, would be a larger westerly number. Sorry, let me focus my thought here. When we're looking at this, is kind of like an aid to navigation, if you will. If we are getting a bearing for whatever this A is, and I look at my compass on board my vessel, and I think my bearing is somewhere around 060. But in true, if I was to plot this on the chart, I need to plot it in true. And that would be 040-ish. So we're talking about our true north, but when we're actually, navigating our vessel with our heading or taking bearings, that number is going to be, these numbers that we are applying to our heading, we can apply to, or to north, we're applying to our heading as well. Okay, we're going to go through a few examples of these. Again, these is going to be for variation east and deviation east. So we have our true North Pole, and our magnetic North Pole is to the right. It's towards the east. And then our ship's compass, or boat's heading, is even further to the east. So our variation and deviation are both easterly in this example. In this example, we have a variation of west and a deviation of east. So we have our true north is the outer circle, and then we have our magnetic North Pole is pointing, what, 22 degrees here towards the west. So we have this variation, because variation is the difference between true north and magnetic north, is pulling us 12 degrees to the west. But then our compass on board is still to the west of true, but a little bit to the east of the magnetic North Pole. So our deviation compared our compass to the magnetic North Pole is going to be east. And then we have our compass error. So again, that compass error is kind of the combination of deviation and variation, or that total difference between true and what our compass is reading. That's going to be our compass error. So our compass error is still to the west, because our variation was so large, our deviation was much smaller. Okay.
Are we gonna do practice problems to understand this more?
Here's our practice problem. Okay. Practice problem. We are on a true course of 045. Our variation is 10 degrees east. What is our compass course should we steer? So we're going to draw out. We're going from true to compass. So we have a true course of 045. We see on our chart that we have a variation of 10 degrees east, what compass course should I steer if I want to make good this, 045 degrees true? So I put in my TVMDC, add west, minus east, and I have my T045, that's my true. My variation is 10 degrees east. And then I apply this. So if I have 045 and then my variation is 10 degrees east. But if I'm going down here, my rule is that I'm going to be adding west. So this 10 degrees east becomes a negative number. Oops. It becomes, so my magnetic is 035 because I subtracted that number, because going from T to M to C, I'm going to be adding west, but my value here is east. So I'm changing the sign on it, if you will. So I have magnetic of 035, and then I want to figure out what my deviation is. So I'm going to go to my deviation table. So everyone look at that deviation table. And under magnetic heading, we're going to find 035. Our M heading is 035. We have a range from 028 to 038. It gives us a deviation of 3 degrees east. So we're going to put 3 degrees east in for deviation. We have our sign here is east, and we're going to be adding west, so we have to subtract east. So I get a compass course of 032 per standard compass, per ship's compass, PSC. So if I want to go on a true course of 045 and I'm steering on my boat using the magnetic compass, I'm going to steer 032.
I have a question. Does that deviation change like that? It's not static around the compass heading? Goes up and down?
Yes, it goes, it's dependent on what your heading is.
That's weird, but okay. That's neat. That's interesting.
So are you subtracting 10 from 45 because it's west, which you're getting the 35 from, and then you're using the deviation table to find 3, and then again it's east, so you're subtracting 3 to 35 and you're getting 32.
Yes.
Okay, and if it was west, then you would be adding them?
Correct.
Okay, makes sense. Cool. Thank you.
So our rule from T to C is going to be adding west, subtracting east. So our east, we're subtracting. Okay, let's do another one. I promise we'll take a break here in a minute. Just bear with me. Okay, so now we have a compass course. So I am steering on my boat. I'm steering 180 degrees with my compass. What is the true course that I'm steering? If I was to plot what I'm steering on my chart, but I want to steer 180 on my boat, what am I actually doing in relationship to the true north? So the most common way to do this is to work at TMVC, but kind of work it backwards or up, if you will, is kind of the common way to phrase it. So I'm going to put my 180 PSC in for C. And now I'm working this formula to go from C to T. So in this case, I'm going to be adding east, going from C to T. I wish I had an arrow on here. So I'm going to start here. I put in a value of my 12 east, but I haven't gotten there yet. I need to start with my C because that's what I have. I have my compass course of 180. And my question is, what is my true course? So I'm working this from the bottom and going up. So my rule here is going to be adding east, subtracting west. So with my compass heading of 180, going to my deviation table with my compass heading of 180, what is my deviation?
1 west, yeah.
1 west. So I'm going from C up. So I am going to be doing the opposite because my rule here is adding east. Oops. So I'm going to be subtracting that 1 because that 1 value has a west. So I get 179 as my magnetic. And then I have 12 east as my variation. I'm going to be adding that east. So 179 plus 12 gives me a true of 191 degrees true.
I'm sorry, how do you know whether you're using west or east?
It's given to us on the table or given to us on the compass rose.
Perfect. Cool.
So anytime we see a deviation, it should have an E or W next to it, that value next to it, or that signifier east or west. And again, that's telling us, you know, which way we are if we're looking at the whole picture there. Okay. Okay, let's take a breather here because I feel like that was a lot of information for us. Let's come back at 8 o'clock. And I think we have like 4 more slides left. And then we're gonna work on this on the chart. And then our homework is a lot of practice of this TVMDC. So after the break, we're gonna be working on the Long Beach San Pedro channel chart. So grab that one out and I'll see you at 8 o'clock. Okay, let's finish this PowerPoint real quick and then we'll get into our plotting. Okay, so we're going to briefly talk about, because our homework assignment talks about getting bearings. Week 5, we dive deep into bearings and LOPs and what they are. So we're just going to kind of introduce them right now. But a bearing or an LOP is what we use as a way to get position, if you will. An LOP stands for a line of position. So the technical definition is basically infinite possibilities along a line is a line of position. So if I decided that I was due south of Brenton Reef Light, and that's the only piece of information I have, I can draw a line due south of Brenton Reef Light, and I am infinite possibilities somewhere along that line. And that line can come, it's not necessarily a line. It can be an arc, a distance. Say this example here is I'm 4 miles from this point. So if I know I'm 4 miles from this point, I can draw an arc of 4 miles and I'm somewhere along that arc, but I need another piece of information to actually know where I am. You can have a tangent bearing that's used on radar. A range, this is my favorite LOP. A range is when you have two things in line with one another. So if you have the jetty and the end of a jetty and the safe water mark, and you line those up exactly, like you are cruising along and they're separate, and then they line up exactly, and then they're gonna kind of do that bearing shift, right? If as you're moving along, two things will have a bearing shift to one another. If they're exactly in line, the name for that is a visual range. So the cool thing about that is you don't need a tool to measure that. You don't need a compass. You don't need a handheld compass or radar, something to measure distance or anything like that. You can just visually see two things in line and get a line of position. But anyways, how we are going to be talking about these lines of positions is through those degrees. We're going to give them values like 045 true, 045 compass. We're going to give them these values. And I want to differentiate here. There's a difference between a heading and a bearing. So on board, you can get bearings using a compass on board, using a handheld compass, using a radar, using, I would say pretty much that's how you would get a bearing. So I would say typically for recreational boaters, you're going to use a handheld compass or a stationary compass on board. And as your boat is moving along, you can look at that compass and line it up with an object, a light, a buoy, something that is plotted on the chart, and get a line of position from it. Another way to do that, if you don't have that compass, if you're not comfortable measuring with a compass or a handheld compass, you can literally change the heading of your vessel to be pointing directly at that buoy or directly at that light, and then your heading is the bearing. But most times your heading is not going to be the same as your bearing. Those are two different things. Does that make sense here? We're heading in one direction and we're getting bearings of where things are around us, but our heading is still the same. We haven't changed our heading. Okay. This is an example of that visual range. And when you see two things in line, a stack and a tower, I'm going to say man-made ones. There's many man-made visual ranges for entering a channel. I don't think Newport has one. I could be wrong, but I don't think Newport has one. When you see, I wish I had a picture of it. They're very large, basically boards, if you will, and then it's kind of striped. Okay, I'm gonna draw it. So as you are cruising along, you want to keep these in line, and that keeps you in the channel. So if you see these ranges, oops, like this, the channel that you want to be in is if those were in line. If you are seeing them like this, then you need to steer to the right to get them back in line. So that's that bearing change, if you will. You want to keep them in line to maintain the channel. So there are many man-made visual ranges, but you can use the same concept on anything, you know, the end of the land and a buoy. I would say that's going to be a very useful one for you guys. But any two objects that are plotted on the chart, that's the key to that. Any two objects that are plotted on the chart. So it can't be, you know, an anchored boat and a buoy, because that anchored boat isn't plotted on your chart. Okay. You can also get a position. So we need 2 lines of positions to get an actual fix. And we're going to go into this again in week 5. But you can have an arc and a line of position, and then that gives you a fix. Okay, we did that one. For our deviation table, our deviation is based on the heading, not the bearing. So I want you guys to really highlight this, exclamation point, star it, whatever it is. I like to actually highlight the word heading on your deviation table so that you are using your heading to enter the deviation table, not the bearing. I'm going to say this is 75% the most commonly made mistake on US Coast Guard exams for 100-tonners. But always enter your deviation table with your heading. Even if you are computing this bearing from a compass bearing to a true bearing, the deviation is going to be based on your heading, not the bearing. We're based on heading. Okay. Now moving on to any questions with that? Let's start there. Any questions so far? Okay, we're going to kind of step into a topic that I touched on earlier. For bearings, we have relative versus true bearings. So that relative means we're changing that due north to the head of our boat, the bow of our boat. That's going to be our baseline. So if I said, we'll go with this picture on the right here first. If I had a lighthouse here and it's, you know, at my 3 o'clock, if you will, or it's on my starboard beam, that's going to be relative to my heading. My bow, it's 90 degrees to starboard. That's my relative bearing. Now, my true bearing, I would have to, if I want to apply that to my, to the true north, I would add in my heading. So if I have a heading of 45 degrees and then a relative bearing of 090, it's 90 degrees on my side, then I could get a true bearing and plot that as a true bearing of 135. So those relative bearings are, I'm going to say, they're not as accurate to get, right? Because we don't have an instrument that really measures from the bow to wherever it is. So the most common way, and we're going to go into this, I think week 6, is to use something on board, like use, you know, the part of your cabin to line up, oh, that is exactly on my beam, or 2 of the winches, or 2 whatever on board to get a relative bearing to your vessel itself. And then hopefully you know what your heading is, and then you can apply that. So again, this is another example of relative bearing. We have from our bow, our relative bearing is from the bow to whatever the object is. But if I wanted to apply true, I would apply my heading and the relative bearing to get true from true north. So my way of calculating this is RST. So R plus S equals T. That's your relative bearing plus your ship's heading gives you a true bearing. So this is an example of it. We have our ship's heading here of 045. If we have something, dead astern of us, it's 180 degrees relative. I guess these are all talking about relative things. If something's on our port beam, it's 270 degrees relative, et cetera, et cetera. So these are relative from our ship's heading. Now we're going to apply numbers. If I wanted to know what this value was to plot it, I would apply my ship's heading, or my relative first, 135, plus my ship's heading, 045, to get the true heading of 180, or the true bearing, excuse me.
And these are all true compass headings.
Yes. Okay, then we have an example where we have a large number. We're looking at this D. We have a relative bearing of 340 degrees. So it is on our port bow somewhere, right? 340 degrees. It's 20 degrees to port. And I have a ship's heading of 045. I add those up and I get this large number, but we can't have that as a value. Our values are only 0 to 360. So then you subtract 360 from it and we get a true bearing of 025. So this is playing with my R plus S equals T rule. Sometimes people want to change this to just -20 because it's 20 degrees to port. That's easier for them. So if you have 45 degrees as your ship's heading, -20 because it's 20 degrees to port, that equals 025 as well. This isn't a crazy topic that we're going to dive into a lot, but just kind of wrap our head around the concept of relative bearings versus true bearings. And our assignment number 6 is all about relative bearings. Yes, so we have, yeah.
So is this for charting purposes, the true bearing, or is it still called the true bearing if you're doing this based on the compass on your boat?
You are, for charting, you're converting it to a true using, so you can plot it on the chart. That's our goal, is to be able to plot a bearing line on the chart. So if you calculate your ship's heading in compass and then applied, you just looked at your ship's heading as a compass unit, and then you applied your relative, then you need to convert that compass to true to plot it on the chart.
It's a way to make sure that your heading is still correct. Being able to calculate your bearings, and true is on the chart, checking the chart versus what your heading is to make sure you're still on the correct heading. Is that right, Bree? Is that why we would be doing this?
For relative?
Well, if I'm checking my heading on my compass,
Yes.
and then I want to go back to the chart and make sure that I'm still correct. You know, I'm passing a landmark, and I'm taking a bearing off that landmark and applying it to my chart. I
Yes.
have to be in true.
Correct. I guess I'm not following what the question was there. That's
No, I
that's
just-
correct.
Why would we want true? And it's just to make sure that our heading is still correct as I'm looking at a chart, right?
Yes, and to make sure your position and your heading is correct.
Right, okay.
So every time we're going to plot a position, you want to either say, yes, I can continue on this heading that I'm on, or maybe I should adjust this one way or the other.
I guess my question is, if I'm actually sailing or on a boat going someplace and my compass heading reads 90,
Mm-hmm.
and then the bearing for the object is 180, the relative bearing is 180,
Mm-hmm.
that would mean on the compass that I'm looking at on my boat, it would say 270.
Correct.
As the true bearing. But if I would then need to convert that using the method that we talked about before to plot it on the chart and to compare it against the chart, correct?
Correct.
Okay.
Correct. Okay, so let's go to the chart. So we have, for this week, we have assignments 5, 6, and 7. So 5, we're going to try to get through tonight. We'll see how we do. We have an hour, so I think we can do it. And then 6 is going to be no chart needed for 6. It's just kind of a review on relative. It's a little bit of a strange assignment. I'm not a big fan of it, but it's in the packet. And then assignment number 7 is going to be practicing your TVMDC or CDMVT, whichever one you use, over and over and over and over again. So our chart plotting, we only have 5 questions, but then our assignment 7 is really practicing that compass error formula for you guys. So we probably won't get to that on tonight or this one tonight, but we will work on number 5, or yeah, assignment number 5. Okay, so camera here. There we go. Okay, so for number 1, for assignment 5, it says you are sailing on a course. So I have a heading of 298 degrees PSC. At 0830, we take a bearing using the ship's compass to find Hoag Hospital, bearing 061 PSC, and the south stack of the Huntington Beach Power Plant, bearing 070. What is our position, our 830 position, and what's our true course? So this is the So they gave us Hoag Hospital is bearing 061 PSC, and HB is bearing 007 degrees PSC. Okay, I want to know what my position is and my true course. So I can plot it on the chart. So this is everything per compass, and I want to put this information on the chart, so I need to convert it all to true. So to convert it to true, I make my table. I'm going, in this case, I'll just use TVMDC. I'm starting with compass. So I'm working my way to true. So my rules are going to be adding east, subtracting west, because I'm going from C to T. Okay, then I make a table because this is the easiest way for me to do it. I'm going to say, what is my heading? What is Hoag? And what is HB? So my compass heading was 298 degrees. My Hoag bearing was 061 degrees. And my HB, my Huntington power plant, was 007 degrees. So far, I've just created a format of how I'll plot or how I'll calculate this. I haven't come up with any new numbers or anything. So I'm starting at C, and I'm going to work my way up to true so that I can plot my true things on the chart. So my first step in doing this is to see what my D is. I have to go from C to D, apply my D to get M. So I need to look at my deviation table. My compass heading was, or is, where's a ruler? 298. So I have compass heading, and I'm looking for 298. So I'm going to say 298. I have 285 to 298 on my compass heading column. So I get a deviation of 6 west. Do you guys get the same? Okay. So I'm going to say my deviation is 6 west, and that is the same because my deviation is applied with my heading. Then I'm going to apply it to get my magnetic. So I'm going to follow my rules here. I have add east, subtract west. So I'm going to be subtracting this number. So I get 292, 053. 0.5. Yeah, 0.55. And 0.001. Oops.
And why is the deviation the same for everything?
Because deviation is based on heading.
Got it. It's just
Based on heading. So this is our heading. These two are bearings.
it's just the deviation for everything then. Got it.
Correct.
Because of our heading.
Because of our heading. Okay, so then we need to apply our variation. So let's look on the chart. We have a compass rose here. What does our compass rose say here? Focus it. We have 12 degrees east, 2017, with our annual increase of 5. So we are going to use, move this again. Okay, now we're going to use 12 degrees east.
So we don't have to adjust it then, just for now. That annually.
I adjusted it in my head.
Oh, okay.
Let's say round down.
Which we kind of did that earlier, right? We had 12 degrees east in 2017. And then we had a 5-minute decrease annually. So that's 4 years. So we're subtracting 20 minutes.
That's right. It was still
11:40
which rounded up to 12.
east. We're still going to use 12 degrees east.
Is it advisable to do that before you even leave? And that should your charts already be kind of, should you change that compass rose beforehand just so you've got it done at a time?
Yes.
All right, cool.
Yeah. So for all of the work that we're going to do for this class on this chart, we're using 12 east as our variation. But again, that's relative to where you are. So if you're down in San Diego, you need to look at that compass rose. Or you're up in the, Channel Islands, you need to look at that compass rose.
Bree, what if with the adjustment, it's right in the middle with the annual decrease or increase, and it's right in the middle with minutes. So instead of let's say 20 minutes, it was 30 minutes, and all of a sudden you have 11 degrees and 30 minutes. How would you round that? Up or down?
So I guess I would round up. But you could say your deviation is, or your variation is going to be 11.5 degrees east. You're just going to get a more accurate true and a more accurate other one. So you can do that. It's just going to be simpler for this class to round to the whole degree. And then I also, when you asked that question, I just wanted to say, err on the side of caution. So if you are, sailing down the coastline and you're at 0.5 towards this way or 0.5 this way, go with the offshore. You want to stay away from dangerous things. So that's just my knee-jerk answer. But just for the simplicity of this class, we're going to do whole degrees. Okay, cool. Okay, so we have 12 degrees east as our variation. East, we're going to add. So we have 292 plus 12. 304, 055 plus 12, 7, 6, 0, and 12 is going to be 0, 1, 3 degrees. True. My math right on that? I tend to do mental math wrong, especially when I'm on video being recorded. Okay, so this is true. So these values are what we can now use to go to the chart. Everything we put on the chart is going to be in true. So let's go to the chart. And one of the first things we have to do is to correctly identify the things that we got our bearings from. So we got our bearings from the Hoag Hospital. It gave us a latitude and longitude. They're going to tell us it's the building here, right off Newport Boulevard. And it says hospital. So that is going to be one of our bearings. And then we have the Huntington Beach stacks from the power plant here. And it is going to be the southeast stack. So the one closest to Newport there. That's our other bearing. Hopefully you can see it on the chart. Maybe I'll zoom in a little bit. So we have our stack and our Newport Hospital. So I'm gonna go with the hospital. Hoag Hospital is bearing 067. So I'm going to put my pencil, I'm going to do it with my triangle, and then I'll do it with the roll plotter. So you'll get to see both. So I'm going to put my pencil on the building, the Hoag Hospital, so I have something to bump into. And then I'm going to put that focal point on a vertical line. So in this case, I'm using this vertical latitude line here. And then I'm going to find 067 where it crosses this line. So I need to find 067 and line this up. So it kind of takes a little wiggling here. 068, 067. Okay, so there is 067 on the bottom of the triangle. And that focal point is on the line. And my pencil is already here. So I'm just going to push down and draw a line. So with this information, I am somewhere on this line. I don't know where. But with the information from the other LOP I got, I can figure out where I am exactly. So let's use a roll plotter. So my roll plotter, my HB stack, so I've identified it, it's the one closest to Newport here, is bearing 013. So I'm going to find 013 on this compass rose. Here's 10, 15, here's 13. There's 013. And then I'm just going to roll it over to the stack, put my pencil there, bumped up against my pencil. And then I'm going to draw my LOP line.
Could you do it with a triangle?
Yes.
Sorry, thank you.
Okay, so I put my pencil here and I'm looking for 0, 1, 3, which is pretty close to vertical. I don't know if we'll reach it. If I run out a triangle. I'm gonna run out of triangle. Okay, so for this one, this is good. This is a good example here. Okay, let me make sure it's squared off here. You guys can see. So first, I'm gonna find 0, 1, 3 without putting my pencil on it. So I'm gonna find the focal point on my vertical line and then 0, 1, 3. So I have 0, 1, 3 and the focal point. So that this side of my triangle is equal to 0, 1, 3. And then this is where you get to a move of the triangle. You get to put a straight edge. You can do a ruler, you can do whatever, on a short side of the triangle. So I'm going to hold this. I'm going to put it on the short side of the triangle. And then I can move this triangle. So I'm here. I'm going to move it. Camera's stuck here. Move it to where it hits that power plant. And then draw my line. So again, to move your triangle, and again, you move it when it's close, pretty much when you're close to a vertical. It's a lot harder to cross a vertical line when you're measuring a vertical line. So when it's close to vertical, that's when you tend to have to move it. So I found the angle that I wanted, 0, 1, 3 on my triangle. So I have my focal point and 0, 1, 3. And then I need to move my triangle. So how do I move my triangle? By bumping up a straight edge on the short side of the triangle and then moving it, you move it about an inch or two till it goes where you want it to go. Okay. So with these two lines of position, I can say here is my 0830 position. So if at 8:30 I got 2 LOPs, and I could plot those LOPs, say this is where I am. Then I also want to plot my heading. My heading is 340. So I'm going to put my pencil there and find 304, excuse me, 304. And I'm headed back to Newport, or excuse me, headed back to Long Beach on 304 degrees true. So here's my position. That's what I'm doing with my heading. I would say that looks pretty safe. If I maintain this for the next hour or so, depending on what my speed is, of course, I'll be pretty safe.
Wait, could you do that last step one more time or explain it again really fast?
For the heading?
The last line, yeah, the 304.
So 304 is our heading. So we are steering that
Oh, right, yeah, yeah.
PSC. We converted that to 304 true.
Mm-hmm.
So now I want to plot that so I can see if I continue this heading, where will I end up? I got a position, I'm okay here, but if I continue on that heading, am I going to run into a traffic lane? Am I going to run into an oil rig? What am I going to hit here? So that's why I want to plot my heading line. And then we're eventually going to project out where we're going to be at certain times. But we'll get into that next week.
So what did you line the triangle on to find that last one?
So I put my pencil on my position. I used the vertical line, and then I found 304. So
Oh yeah, I got it.
in this
Yeah.
case, it's my red ones. Okay. I'm gonna have to move my screen here to get to Point Vicente for number 2. But does anybody have any questions while I'm moving this?
Thank you.
Okay.
And Bree, I assume there's like apps for this, right? You could punch in stuff, solve for the variable.
Yes, I couldn't tell you a certain app, but
But it's
there's not- there's
could be
every-
dangerous to do too. Yeah, it's better to do it by hand.
Yeah. And this is, the reason we're taking this class, right, is to know what our electronics are doing or what our electronics are telling us. Because yes, this is the day and age where we rely on our navigation systems to get to the grocery store, let alone sailing out at sea. So, but we want to know like what they're doing, so we're not just completely relying on the numbers they're telling us.
Yes.
Okay. Okay. So number 2 tells us we are steering 107 degrees PSC. Point Vincent light is bearing 314 degrees PSC. And Point Furman is bearing 044. What is at 12 o'clock? What is our true course and what is our position? Oh, I forgot to do the position on the last one. I'll do it on this one. But hopefully we've mastered that in last week's homework, right? Okay, just kidding. I'll do it on the next one. Okay, so I make my table. True, E, M, D, C, and we have heading, point B, point F, Okay, so if we are starting see, point B 314 and 044. So if we're starting at C and working our way up, we are going to be adding east, subtracting west. So our first step here is to figure out what our deviation is. So for a compass heading of 107, what is our deviation?
Five east.
Here we go. 5 east. And we're moving up our equation here. So we are going to be adding do our mental math here. And what's our variation that we're going to use?
12 degrees east.
12 east. And east, we're going to add so that's 124. So I got my true values. And now I can go to the chart to plot those. So we need to find these. So both of these are going to be lights. So we're looking for Point Vicente light. So it's going to be that little dot there, Point Vicente. And then Point Fermin is down here. And Point Fermin light is going to be that guy right there.
Have we talked about how we get these bearings? Are we just eyeballing it off of our boat?
No, you want to use a tool. The more accurate you are, the more accurate your position is going to be.
And we'll talk
But
about
we're going
these.
to talk more about getting those LOPs in week 5.
Okay, good. Thanks.
Okay. So, let's see. Point Vicente was bearing 331. So I'm going to put my pencil on Point Vicente. And let's see. Don't think I'll be able to find 331. So I'm going to do 331. It's a repeat of last week. All right, 3, 3, 1. And then I'm gonna slide this over.
How are you finding 3, 3, 1 again?
Okay, let's zoom in on this if we can. So I put the focal point on a vertical line and then 3, 3, 1. So here's 3, 3, 0. So 1 up from 3, 3, 0 is 3, 3, 1. Let's see. This one might be easier to read. Yeah, that one kind of easier to read.
So you're putting the focal point on there, and then are you moving the focal point to Point Vicente? And then
No. Then I'm putting a straight edge on the short side of the triangle. And then I'm going to move my triangle to where that long side of the triangle touches Point Vicente. And then I can draw my line. I'm gonna draw mine a little bit longer, just in case. For Point Furman, I had 0, 6, 1. So I'll have pencil. I'll be able to get 0, 6, 1. I'm in the purple here, so it's a little bit harder to see. But I have 0, 6, 1. And the focal point, I'll draw my line.
Where'd
So
you
I did
061 from?
that is my bearing for Point Furman.
Thanks.
Okay, then I want to plot my course. So my heading is going to be 124 degrees true. Put my pencil on my position. And then I'm going to find one. Move this a little bit down. Right, can we see Point Furman? There we go. All right. What kind of questions are you guys coming up with? I know I'm doing it way faster than you guys, so I want to give you time to do it. Do you want me to show you something with the roll plotter? I know I haven't used that one.
Is there a way of calculating your true heading with the line of position? I mean, I know that's a deviation from our assignments and everything. There aren't that many line of positions on this particular chart. South of
Talking about
Long
the
Beach.
compass rose? What do you, the line of position is something that you're getting. It's not on the chart.
But like an arc or a tangent, that I deviate that from the compass rose? I guess maybe
No.
I all the questions in the assignment are all based off bearings. But I was just wondering with regards to the line of position, like a range or a tangent,
Yes.
isn't it something physical
Wait till we
marker
get
that's
to
on the
number
chart?
4 or 5.
Oh, okay. Sorry.
We got ranges on 4 and 5.
Got it. All right. Thanks.
Yep.
Boy, Rose, using the parallel bars is so much easier for me. They're
Parallel.
just so much more intuitive.
Yes.
Using the compass rose and parallel bars is what I grew up with, so that's just very intuitive to me.
Just stick with
Your
that
triangle
then.
confuses me.
And I can show you using the parallels if you would like.
That's okay. I did it myself, and I came up with the same course headings and everything that you did.
Okay. Just let me know. This is one of those distance learning things. Like I'd like to walk around and use the tools that you are using with you. But with distance learning, I'm guessing at what tools you guys are using. Okay. So let's keep going so we can get through some of these. Okay, so number 3, we're down in Catalina, so let me move this. And it's also gonna throw us for another little loop here. We're doing Shipsbrook and Long Point. Oops. Oops.
Do you align the true, for the last one, do you align the true, the 124 on the latitude, and then that's your 12,000, your 1,200?
Why isn't this working?
Oh, sorry.
Sorry, my document camera's frozen. Heck.
That time. It's at 9, always.
I know it's on now. I just. Okay, hold on. This is really gonna be bad. It was just a plug issue last week. Okay, I'm gonna turn this off.
Are we supposed to write the time at the point where the bearings are taken?
Yes. So I've labeled it here, my LOPs, I circled it and put a time, And then I put my course for my heading 124.
Okay, so it is 124 that you go into the direction, but you just put 12 o'clock.
Correct. That's
Okay,
12
got it.
o'clock.
Awesome. Epic.
Okay. Okay, so for number 3, this one's an interesting one. 1800, we are using a handheld compass. I know we haven't gotten into our different tools. Oh my God, seriously? Okay, sorry. I know we haven't gotten into our tools, but according to US Sailing, this is how they like to teach this. If you're using a handheld compass, that is a magnetic compass and it doesn't have any deviation. So we go straight to M instead of using, so let's just, I'll write it out for us. It says 1800 using a handheld compass, we take a bearing of Ship Rock at 234 degrees M, and long point was 157 degrees M, and my heading is 100 degrees PSC. So if you are taking a US Sailing exam and they say you are using a handheld compass and they give it to you in M, you're going to go straight to the M. If you're taking a Coast Guard exam, they will never give it to you in M. They're going to give it to you in C. And you put it where the, or PSC, and you put it where the C goes.
I just want to verify that the heading is
What's your heading?
0, not 100 PSC.
Should be 160.
There's a discrepancy on the answer sheet and the question. So the question
Oh,
so the question shows 160 and the answer sheet shows 100 as the heading for question 3.
Oh, thank you.
Okay. Okay, so I changed it to 100. So change your questions so that our heading is 100.
mhm.
So the one on Google right now, the answer or the worksheet has it as, let me write this down. Please let me know when you find typos and stuff. I want to make it better. Okay, so number 3, heading 100. Okay. Okay, so let's plug this in. Need a little space here. So our heading is 100, but our bearings that we got with our handheld compass doesn't have deviation, because they're saying our handheld magnetic compass is pointing directly to the magnetic north pole. So if you have like a cell phone next to it, it's not going to change it at all. I don't really think that, but anyways, I'm not going to, let's just go with it. Ship's rock has 2, 3, 4 degrees magnetic, and long point is 157 degrees magnetic. So I'm still going to use my deviation table for my heading. My heading was 100. So that's 5 east, right? Yeah. I think our answer sheet is wrong on that. 5 degrees east. If we're going this direction, we're going to be adding east, subtracting west. So we're going to be adding that number. So I have 105 degrees magnetic. Then I'm going to apply my variation that's on the chart. Where's my compass rose? As 12 east.
Bria, I thought you said a handheld compass didn't have deviation.
It doesn't have deviation. It does have variation.
So why are you putting down the deviation? Shouldn't that be 0?
I'm putting down variation. I'm putting it where the V is. So the
I know, but you have 5 degrees E on the deviation.
That's for my heading. My heading was in PSC. My bearings were with a handheld compass, but I'm steering my boat with my boat's compass.
Okay, I understand. Thank you.
Okay. So 12, we're going to add, because it's east. So that's 117. 4, 2. Make that a little clearer. 246. And 169. So I have my information in true. And I'm going to plot it on the chart. Are you guys with me on these numbers? Okay. I don't even know what I'm trying. Okay. Oh my gosh, seriously. Okay, so we have ship rock, it's going to be right here. And then long point light is going to be over here. So we have Shiprock and Long Point Light. This guy was bearing 246. So I have 246 on this side of the triangle, focal point, Shiprock. Oops. Shiprock. 246. Draw my line. Then I have, I'm gonna say I'll probably have to move this one. Don't have enough space on here anyways. Oh yeah, 169. It is vertical. 169. So focal point and 169. Bringing it over to long point. Just barely crosses. And that was at 1800. That's my position. And my heading is all right. How you guys doing? Okay.
How do we start the 17 again? Or the last on the converging points?
117. We got that
Go ahead, sorry.
value. Okay, we only have 8 minutes left here, and I want to show you that the one where we're not using straight lines, we're using arcs instead. So I know you might still be working on this, but I'm going to jump to number 4 so we can get to that one. Let's see, here we go. Okay. Okay. Yeah, okay, I got both of them on here. Okay. So in number 4, they tell us at 9:45, the oil platform EVA has a range of 3.9 nautical miles. And buoy LB, that's a buoy, this is going to be an oil platform, has a range of 3.5 nautical miles. Also know that we have a depth of approximately 100 feet. What is our position? So here we are not doing a compass error. We have distances. So these are distances that we're going to measure using our dividers / compass. So I am going to use my tool that has a pencil end and a pointy end to create an arc. So I know you guys, I can't show you. Okay, I'm just gonna do it right here. We're gonna get I'll show you on the whiteboard and then I'll show you in person here. So we are gonna get from Eva, we're 3.9 nautical miles. So I'm gonna get 3.9 on my tool and then create a circle. At this distance is 3.9 nautical miles. Then I'm going to get 3.5 nautical miles. .5 nautical miles. Someone's asking a question here. Hold on. Okay, so we have an arc of position of 3.5 nautical miles and an arc of position that's 3.9 nautical miles. This crosses in 2 locations. So it gives us 2 possible positions. So anytime you have a range, or especially 2 ranges, you have 2 possible locations. Sometimes they're so far away, or this is covered by land and you're like, obviously that's not it, this is it. Or whatever. Sometimes it's very obvious, but you need one more piece of information. That can be looking out the window to say, oh, that oil rig is to port instead of starboard, or a past position might help you, or a depth in this case. We're going to use our depth to help us decide which one we're at. So let me create those arcs. .5 was LB. So here is our LB buoy. And I'm going to create an arc. It says I'm somewhere along this arc. It's 3.5 nautical miles. Here's my Eva platform. And I'm going to draw an arc. I'm somewhere along this arc at 3.9 nautical miles. So that puts me here or here. It crosses in 2 locations. So they told me the depth was about 100 feet. So what is my depth here? I have a 7 and a 9. 7 and a 9. And remember, these are in fathoms.
It's like 50 feet or so.
So I'm going to go down here. My 7 is about 42. 9 is about 54. So somewhere about 50 feet. Here, I'm pretty close to that 17. Here's a 15, 17, 15. So let's see what 17 is. $17 is 102. So I'm going to say this is where I am at 9:45.
Reed, did you use a scale at the bottom of the chart to know the 2 points on the compass so that when you were making your arc, you knew what was 3.9?
Oh, okay. I use this scale
Sure.
down here for fathoms to feet. To measure my 3.9.
Yeah.
Did you use the latitude?
I used my latitude here. So I went from 30 to 3.9.
Perfect.
Measured that, and then you could see where I did my 3.5.
Mm-hmm. Mm-hmm.
Okay. So, covered a lot today. Definitely keep practicing. Watch some of the YouTube tutorial. I go over this assignment. I'm also going to record this class. This session is obviously being recorded. I'll post that. Last week, again, was my technical error week. It took me like 2 days to upload that video. So hopefully I'll get it uploaded tomorrow. If not, it'll be uploaded Friday. Let me know during the week if you guys want to do a Zoom session or this weekend. If you guys are stuck on something, I completely understand your frustrations. So I don't want you to be frustrated. Shout out, let me know. I'm here to help. Next week, we're going to be doing distance, speed, and time. And we're going to be going back to that training chart. We're going to be going back to Martha's Vineyard Sound. So, so we'll do that. You guys got any questions for me? You guys doing okay? All right.
Thank you.
Hope you're doing well. Have a good weekend, guys.